Hello, in this video I'm going to show you how we can reach the same formula as before for Doppler laser or Doppler radar, but using another definition, and that is phase shift. Before that, we need to know what a phase shift is and how my wave formula is going to look like. If this axis of x is going to be my time axis and this is going to be meters, how high my waves would go. Let us say we are talking about waves in a lake, and I'm standing here as an observer at position 0 and time 0, and at that moment my wave height is 0, and let's say at time 1 it is 4 meters above, at time 2 it is 0 again, at time 3 it is -4, at time 4 it is 0 again, at time 5 seconds it is 4 again, and then 5, 6, 7, 8, 9. So we need to write a formula, and for that I can say y, and that would be my height, of x, because I want to know the position, would be so right now we can say how does it look like. Does it look like a sine or cosine or whatever? Is it a tangent? Is it a cotangent, or what is it? It is started at 0, and at 0 it is 0, then at 90 degrees or 1 second later it has reached its full capacity, so definitely it is a sine. So I write here sine of whatever, but before that I might want to consider something else, how high my wave is going to go, and it is from -4 to 4, and that would be my amplitude. And then I'm going to write well, let's say just an unknown factor like question mark, but that wouldn't do it. If I write x, there would be a problem. And by the way, I can write the general wave formula as a function of time or as a function of meters, so it would be time per second, or for instance this one here could be 1 second after start or initiation, or meters away, or millimeters away, or meters. So it could be my x-axis. There's no problem. If I write it as a function of meters away or x, there would be a problem, because let's say I write here here would be my 180, but that wouldn't be my x. My x is from 0, 1, 2, 3, and if I write a cosine of or sine of 1, it doesn't make much sense. So what we generally do is to write for one cycle, or one cycle, as I told you before, is from peak to another peak, or from trough to another trough, from here to here. I go one wavelength, and then that multiplied by my x would be general formula. Now let us try it. So my wavelength is going to be from 3 to 6, or it is going to be from 1 to 5, so it would be 4 meters. So what I'm saying here, that should actually be 2 pi 1 cycle, from wherever to wherever. And how long am I going for one cycle? So 4 meters for one full cycle, or 2 pi, that should be actually 1. Amplitude here is 4 meters. As you can say, I go 4 meters up or 4 meters down. That's my amplitude. sine of 2 pi over 4 multiplied by x. Now what will happen if I put the value of x here? Now let us try with, let's say, 2. It would be 4 times sine of 1/2 pi or pi over 2 multiplied by 2. These two will cancel each other out, and sine of 180 would be 0. Now let us check it if it is correct. Yes, exactly correct. So we can put a check mark here. Now what would happen if I have a phase shift is that I generally would have the same or equal wave, but it starts at somewhere else. Let's say it starts here, and it is where it is 0, it is going to be 1. So I draw it right here. As you can see, this is my phase shift from trough to trough, and this is actually 180 degrees. So one of the signals, let's call the blue one blue, and let's call the green one G. So I can say which one is leading each other, and I think G is the leading one, because as you can see, at time 0 or at place 0, my B is actually in negative. So I can say my G is this one. This is actually G. Y of G of x is 4 sine of 2 pi over 4 multiplied by x, and B lags behind in this phase, and B would be B of x would be exactly 4 sine 2 pi over 4 multiplied by x minus phi. Why minus phi? Because it is lagging behind. If it was forward, I would have written plus phi. Now the fun begins. In our device, be it radar or lidar, I'm sending a wave. Without a phase shift, it goes and comes back the same thing as it comes. So it would be null. So I'm sending without change. Next time, let's say after 2 seconds, I send my signal and it comes back with a change from the first signal. So I calculate my phase shift, which would be 2 pi over lambda, and since it is going away and coming back, it would be 2d, or 2 times the distance multiplied by 1 full cycle divided by lambda. If as I assume my particle is going toward me, toward observer, or going away from observer, this distance is going to be changed, and this distance is a function of also time, and therefore we write radial velocity, normally shown as Vr, is going to be dt, d over dt, and this is going to be changed. If my phase changes, so that would be actually, if my phase changes, what I would have is, I would have d phi over dt, and that would be, so instead of d we were going to be having Vr, and that would be 4 pi velocity of radial over my lambda. And finally my Doppler velocity is going to be, or frequency shift is going to be 1 over 2 pi multiplied by the phase shift. I would receive something like this: 4 pi velocity r over 2 pi, and it would be 2 times velocity multiplied by lambda, 2 times velocity radial divided by lambda. And if I change these two, remember velocity is going to be frequency multiplied by lambda, therefore frequency is going to be velocity divided by lambda. I can say 2 times velocity radial multiplied by velocity of speed of light divided by frequency. And I'm sorry, because lambda is in denominator, we are going to change the place of frequency and the speed of light, and for that I would receive something like this: frequency. Thank you very much for staying tuned, and have a nice day.